Hello guys, I'm starting with new question and third number question of kinematics series. So let's start to read this question. Myself Saurabh Sharma. So three particles A, B and C starts moving simultaneously with a constant velocity from three places. The starting places are collinear and that of B is somewhere in between those of A and C. In the absence of C, particles A and B would have collided T1 time after they started, and in the absence of B, particles A and C would have collided T2 time after they started. What would have happened if A were not present? Okay, let's see. This is the easy category question, so I'm starting with this solution. So the solution of this question is saying three particles A, B, and C start moving simultaneously with constant velocity from three places. Okay, and the starting points are collinear. So let's assume these are the points and 1A, B, and C are the collinear points. Okay, very simple question. So question is saying that the starting places are collinear and that of B is somewhere in between those A and C. So B is somewhere between A and C. Okay. In the absence of C, the particle A and B would have collided T1 time. Okay. So if suppose this is moving with the velocity V1, for better understanding, I am draw with the different color paths. So this is moving with the velocity. Say suppose it is moving with the velocity v2, and this is moving with the velocity v1. So they collide at somewhere with the time t1. So they collide at t1 time after they started. Okay, so means from A to P point and B to P point, the time taken between them both are same. Okay, now what is the next point is saying that in the absence A and after they started in the in the absence of B, particle A and C would have collided T2 time after they started. So let's assume this is the motion of C, and C is there is a two chances. Maybe C is collided here, C is collided here. Okay, C is collided here, this point Q, and maybe this is collided with this point R also. So this may be T2 or this may be T2. So we can say that A to R, and this is the speed of VC. So either it this going this path or this path. So just choose a one path. So there is a two options. There is a two confusion. So we are going by one. I just tell you, let P is the point of intersection between A and B. Let P is the point of intersection between A and B. And the important points are maybe Q and R are the intersection points. Intersection A points between A and C. So either the Q particle, C particle is collide at point R or at collide point Q. So there is a two chances. So just think and listen carefully. So if it is collide with Q, suppose for point Q, what is happening? For point Q, the time taken T2 is more than T1. So we can say that the T2 is more than T1. But for point R, this T2 point is less than T1 because A will reach early as a T1 if it is collide with the at point R, but if it is collide at point Q, then time taken by A is more than T1. Understood or not? So for point P and for point P, the T1 and T2 must be equal. Why? Because time taken by the A to reach the point P is T1. Understood my point? Okay, so let's assume what is the situation. Situation is saying that if T2 is so what would happen if A were not present? So let's assume the situation here. Here A were not present, so this is the path of A. Let's assume this is a path of A. Okay, this is a path of A, and so this is a path of B, and this is a path of this point C. So I'm drawing carefully. So this is the path of B, and this is a path of B, and there is a two possibilities. One is, let's assume the C is going here. So this is a point Q, this is a point P, and other points are this is a point R. So let's assume there is a two chances. One is the B and C collide at this point or at this point. Understood my point? So B and C are collide at this point or at this point. So actually C is taken time to reach the point Q is T2. So of course if for S collide it takes more time. Understood or not? And for this case, so the time taken by B to reach at this P point is T1 as we know. So the at point V it's take less time. So let S V and one more point is also there, which please don't forget this point. So the points are this P point also. So this is the another path. So let's assume SV and T P are the possible points of collision. Okay, so let's assume if now situations are given. If T2 is greater than T1, we are going by one. If T2 is greater than T1, what is happening here? If T2 is greater than T1, then B and C may or may not be collide. Why it is not may or may not be collide? Because time taken by T2 is more than T1. So there is a situation where the B point will reach here and C point will reach here. Understood my point? Or somewhere here. So it is simply logically we can say that then B and C may or may not be collide. Very nice question. Now what is happening if T2 equal to T1? Then if T2 is less than equal to T1, this is another situation if T2 is less than T1. Okay, so T2 is less than T1, then B and C collide before T2. It is the possibilities. Okay, so I want to give the better clarification to draw the situation. Okay, so let's assume this is the path of A. A path is this. Understood? And B path, of course, B path is this. First case, if T2 is greater than T1. So there is only one chances. to somewhere, the particle, this is the C particle, if it is going like this, if it is going like this, then it will be, this is a time t2 and this is a time t1. So t1 is more than t2, sorry, t2 is more than t1, then there is a chances to at this point as they can collide. But if they are going, C point is going somewhere here, this point is also t2 time. So A reaches at this point is time at time t1, and B is or C is also reaches at this point t2. So there is no collision because the path of B is here and path of C is also here. So there is a chances to may or may not be collide. What is happening if T2 is less than T1? Let's assume if T2 is less than T1, then this is the path of A. Understood my point? And be remember, the time taken by C collide with A is less than the time taken by A to collide the B. So there is a situation, this is the B part. You know very well B is colliding somewhere with A at time T1. This is a collision. Understood? So what is happening? There is a chances to C. If I am talking about C, so if one is this possibilities, the collide is here, so its time is T1 equal to T2. Other one is if T2 is less than T1, then it is covering somewhere. So this is also collide. So there is a two chances where the collide. So we can say that if T2 and T2 is less than T1, then B and C collide before T2. Before T2. This is the point. And at time T2. So this is the answer. Thank you so much for watching this video. Please keep on my channel. Thank you. Bye bye.